Okay, so this is your video for double replacement reaction notes. So when we have double replacement reactions, we're taking two compounds and reacting them with one another and getting two compounds out of it. So this is the journal form, AX plus BY. And what's going to happen is these two ions are going to go with one another, and then the B and the X are going to go with one another. So when we write double replacement reactions, we always write the positive ion first and the negative ion second. And we're going to use our solubility rules only on these problems in double replacement. So on your test and everything else, I'll make sure that I tell you when to use your solubility rules or your activity series, that sort of thing. Okay, so our first example, AgNO3 plus NaCl. So what we're going to do is we're going to take these two ions and put them together. Okay, silver has a +1 charge. Chlorine has a -1 charge. Okay, and then we're going to take the inner two ions and put them together. Na has a +1 charge. NO3 has a -1 charge. Okay, so there's no need to crisscross on these two because they have equal and opposite charges. Now, we're going to go through and balance. So we got one Ag, one Ag, one Cl, one Cl, one Na, one Na, one NO3, one NO3. So it's balanced. Now, the last thing we need to do is to make sure there's an actual reaction that occurs. So this is why we're going to use our solubility rules. Okay, so rules for NO3. All compounds containing NO3 are soluble. So we write AQ past it. All compounds containing chlorine are soluble except for silver, mercury, lead. So it's soluble. All compounds containing chlorine are soluble except for silver, mercury, lead. This falls into an exception. So it produces a precipitate. Okay, and all compounds containing NO3 are soluble. So there's an actual reaction that occurs because you have a precipitate formed. Okay, next one. I'm just going to write it down here. Okay, I'm going to take the outer two ions and put them together. Na has a +1 charge. NO3 has a -1 charge. I'm going to take the Ba and the SO4 and put them together. Ba has a +2 charge. SO4 has a -2 charge. Now you're probably going to ask me, why am I not taking these subscripts over? You don't take anything from the left side to the right side. Those come from the crisscrosses over on the other side. Okay, so we got to balance this. Two NO3s, two NO3s, two NAs, two NAs, one SO4, one SO4, one Ba, one Ba. It's balanced. Okay, now we're going to go through and do our solubility rules. All compounds containing SO4 are soluble except for strontium, barium, mercury, lead. So this is going to be soluble. All compounds containing NO3 are soluble. All compounds containing NO3 are soluble. All compounds containing SO4 are soluble except for silver, mercury, lead, and strontium, barium, mercury, lead. So barium falls into an exception. So you write solid out to the side. So remember, that's going to produce a precipitate. Okay, now copper 2 sulfate. Copper is Cu with a +2 charge. Sulfate is SO4 with a -2 charge. Don't need to crisscross because they're equal and opposite charges. Sodium is Na with a +1 charge. Sulfide is S with a -2 charge. So we crisscross and we get that. So we're going to take the outer two ions and put them together. So Cu is going to have a +2 charge. Sulfur is going to have a -2 charge. Na and SO4. Na has a +1 charge. SO4 has a -2 charge. So we crisscross like that. So we're going to balance. So I have one S, two NAs, two NAs, one SO4, one SO4, one copper. It's balanced. Now let's go through and do our solubility rules. So all compounds containing sulfate, SO4, are soluble except for strontium, barium, mercury, lead. So this is going to be soluble. All compounds containing sulfide are soluble except for, insoluble, sorry. All compounds containing S are insoluble except for ammonium and group 1. So Na is in group 1, so it's going to be soluble. All compounds containing sulfur are insoluble except for NH4, group 1, calcium, strontium, barium. Copper is a transition metal, so it is not soluble, so we write S. All compounds containing SO4 are soluble except for strontium, barium, mercury, and lead. Sodium does not fall into one of those exceptions, so it's soluble like that. Last example problem. Calcium is Ca with a +2 charge. Acetate is C2H3O2 with a -1 charge. We crisscross. Ammonium is NH4 with a +1 charge. Carbonate is CO3 with a -2 charge. So we crisscross like that. Okay. Now, we do our double replacement reaction. We're going to put the outer two ions and put them together. So CaCO3, this has a +2 charge, this has a -2 charge. Equal and opposite, so we don't crisscross. We're going to take the NH4 and the acetate and put it together. NH4, C2H3O2. NH4 has a +1 charge. Acetate, C2H3O2, has a -1 charge, so there's no need to crisscross. Now we're going to balance this. 1 CO3, 1 CO3. 2 NH4s, I need to put 2 NH4s on this side. 2 acetates, 1 Ca, 1 Ca. It's balanced. Now we're going to go through and do our solubility rules. All compounds containing acetate are soluble. So right, AQ. All compounds containing CO3 are insoluble except for NH4 in group 1. So NH4 falls. I wrote this wrong, sorry. Nope, there should be a parenthesis. Okay, so all compounds containing CO3 are insoluble except for NH4 in group 1. So this falls into an exception, so it's soluble. All compounds containing CO3 are insoluble except for NH4 in group 1. Calcium is in group 2, so it's insoluble. And then all compounds containing acetate are soluble, so write AQ. Okay, so in order to have a double replacement reaction occur, you have to have a precipitate formed or some sort of change in state or some sort of change in consistency, okay? And we get that by looking at our solubility rules. So if you have any questions on this, feel free to reach out. Hopefully you have a good night. Thanks.